Hello, my name is Tess Rekabi. I'm a pharmacy student, and today I'm going to talk about a disease that I encountered during one of my clinical rotations, especially in the pediatric population. The disease is called dehydrogenase deficiency or pyruvate dehydrogenase complex deficiency. Okay, our learning objectives for this topic, and I'd like at the end of this presentation my audience be able to define pyruvate dehydrogenase complex, to have an idea what it is and what its main function in our body, be able to identify the causes of pyruvate dehydrogenase complex deficiency, be familiar with the signs and symptoms of this disease, also be familiar to know how to diagnose this disease and what are the current treatments currently, and also we'll take a look at a trial that was done regarding this topic. Okay, before we talk about the disease itself, let's talk about the pyruvate dehydrogenase complex itself. So as we see here, that the pyruvate dehydrogenase complex consists of three main components or enzymes. They call it E1, E2, and E3. And as we see here, that the main mechanism of PDHC is to convert pyruvate. And as we know, pyruvate is a molecule that play a major role in activating a series of pathways that leads to generate energy to the body and especially to our brain. Now, any dysfunction in the three enzymes or the three components of the complex will lead to reduction in acetyl-CoA, which is the end product of converting pyruvate. So the deficiency or the dysfunction of this complex will lead to accumulation of pyruvate and reduction in energy and acetyl-CoA. Okay, this is just an overview about the disease itself. So it's definitely a genetic disorder. It's very rare. It's not common. It's characterized by build-up of lactic acid in the body, and that happens due to inhibition of the pyruvate conversion to acetyl-CoA. So when we have so much of pyruvate just floating around, it'll be reacting with other things in the body, and it's usually get converted to lactate. It's also an X-linked recessive genetic disorder. And what do I mean by X-linked disorder? It's caused by abnormal gene on the X chromosome, and as we know, male carries one X chromosome, while in female they carry two of them, and one of them is inactive. So if the male inherits the X chromosome gene, then the male will have the actual disorder. However, the female will be carrier for the disease. But some of the females, they also may manifest some of the signs and symptoms of this disease. Now, PDHC deficiency can cause a lot of neurological complications, not only motor or skeletal problems, but mental issues as well. As I said, it's a very rare condition. However, it's very serious and deadly, just because we know that lactic acidosis is a very life-threatening condition. And then this disease actually manifests very early in infancy or in late childhood. Okay, let's jump into the pathophysiology of PDHC deficiency. What causing it? So as we said, it's a genetic disorder. So the main cause of this disease is a mutation in the gene that's called PDHA1, which is located at the first component that we saw earlier in the picture of the complex E1, which is enzyme 1. And it's located usually in the X chromosome. There are other genes that it can be associated or found with this disease as well, such as PDHB, DLAT, PDHX, and PDHP1, which these are mainly located in E2 and E3 enzymes or components of the complex, but the main one is the PDHA1 that's located in E1 enzyme. Common signs and symptoms of this disease is poor feeding. A lot of children will get diagnosed with this disease early in their lives just because they cannot tolerate foods, especially carbs. So poor feeding is one of the major signs for this disease. Also, the common feature of this disease is a buildup of the lactic acid, which causes the lactic acidosis condition. Nausea, vomiting, difficulty breathing, and irregular heartbeat also common side effect with this disease. And there are a lot of neurological complications, intellectual disability, seizures. They will have weak their muscles. A lot of children, they will not be able to lift up their neck or arms. That's what we call it, the hypotonia. And they'll also have delay in their walking and difficulty walking as well. The standard treatment of pyruvate dehydrogenase complex deficiency is to administer thiamine, carnitine, and lipoic acid to these patients. The purpose of given thiamine, which is vitamin B1, is usually given in a high dose in these patients, more than 400 milligram per day, which is more than what the usual dose is. Carnitine is also given to facilitate fatty acid transport into mitochondria and therefore increase energy to the body, while lipoic acid is it's a form of antioxidant which helps the cell with energy and reduce cells oxidation. And finally, the pediatrician usually recommend or prefer ketogenic diet just because of this condition. It's hard for these patients to digest carbs. Therefore, protein and fat is the appropriate diet for them. It's make it easier for them to digest food and to prevent any nausea, vomiting, any upset stomach. After we talked about the standard treatment for this disease, I was curious about if there are any new drugs in the market or in the research studies about this disease. And I came across this medication is called dichloroacetate, or short for DCA. It works by inhibiting glycolysis, and glycolysis is the conversion of glucose into pyruvate. So with this drug, it will inhibit the conversion of glucose to pyruvate. Therefore, we're not going to have a whole lot of pyruvate, if any, to convert it to lactate, and therefore lactic acidosis or lactic acid accumulation in the body. So that's what the drug that I found that's currently in the studies. We're trying to see if it actually helps these patients reduce their lactic acid level in their system. Okay, in this trial, we're trying to study the drug DCA, see if it's been helping. So in this study, it's not prospective study, it's more retrospective study. So they collected all the information that they could found from various sites, and they went back from 1985 through 2004 just to see um, what happened to these patients who've been administered the DCA, and did they have any reduction in the lactate level? Did they have improvement in their neurological or motor function? The study's objectives, it was whether DCA will help lower lactate in the system for patients with PDHC deficiency. So the intervention, they didn't talk a whole lot about what's the exact amount of DCA that was given. It was just given orally to these patients. The statistical analysis for this study, they studied 40 cases, which is a very small number, um, for a study. They used the two-sided Wilcoxon test, and then they selected the cases from 1985 all the way through 2004. The age range for these patients was from newborn to mid-age childhood. So the conclusion for the case study that they did is the trial did show that DCA is actually safe to administer. A lot of patients did not have a whole lot of side effects, so it was safe in the trial, and it was lowering lactate levels in the system. However, the patients still had neurological problems, did have motor function, intellectual disabilities. They didn't see a whole lot of benefits from it. The only thing that was efficacious is the lactate acid reduction levels in this system. So my conclusion is that I agree with the author that the DCA was safe, but it wasn't efficacious enough, and we would like to see more future trials done for this medication, at least with a larger number of patients, more than 40 patients for sure, just to see what DCA might do for these patients, and then also monitor them for a long time to actually see the effect of a neurological development.